Continuing our discussion with File IO, now we're going to talk about delimited files. And delimited files come in text form, .txt form, or they can come in other forms, but we're going to deal with them in .text form. And as you recall, when we did CSV files, we had our values separated by commas. And so let me put this example back up here. 1, 3, 42. So this is an array. Our samples are in our file is separated, our data in our file is separated by commas. And so this is the delimiter. Now, what you can do is with DLM files, you can change that. By default and by definition, in CSV files, the delimiter is a comma. But with DLM, and we'll call it DLM because we're going to use DLM read and DLM write in different forms, and we can actually change the delimiter. We can read files that have different things separating their data values, and so that's what we're going to talk about now. We're also going to extend a little bit our capabilities with what we can do here. So let's take a look at this in MATLAB. First of all, we'll start with DLM read, and over here on the right here we have data that's separated by a semicolon. Okay, and so the function is DLM read. Give it a file name, just as we did in CSV, and then we give it the delimiter as a string. And so when we read this, if I execute this, you see that down low, A equals the results of this, which are 2, 5, 7, 45, 99, 7. If I had put a different delimiter in here, let's say if I was looking for a delimiter to be a comma, and I run this, it gives me an error because that's not the delimiter here, right? And so the delimiter can get pretty much as crazy as you want it to be. Let's look at a couple here. If I change this semicolon to the tilde sign, and keep in mind this is all to deal with different formats of data that you may get out in the field. So if I run this, oops, looking for the tilde as my delimiter, and still doesn't run. What's that? Oh, that's the save file. So if I run it, it finds it just fine. If I come here and change it again to, let's say we change the tilde to an asterisk, and save the file, and then I run it. Once again, I didn't change my delimiter here. Let's change that. There you go. Okay. You can also, strangely enough, this has to be, once again, these have to be number-only files. However, even though the files are number-only, what I can do is I can change the delimiter to a character. So let's do this. So now the delimiter is character A. Save the file, come over here, change my delimiter to A, and it worked. You see, it didn't give me an error. It found the data here too. So, so you can make the point is you can make your delimiter whatever you want. However, another version of this is if I omit the delimiter altogether, MATLAB is going to guess, right? And so if I have something that's fairly standard, like a semicolon, if I have something that's fairly standard like this semicolon here, and I tell it to guess, so I didn't put a delimiter in there. I used DLM read, just a file name, didn't put a delimiter in there. It will guess, and it just did. You see when I ran it, it didn't give me an error. It gave me my same array back. It guessed the semicolon correctly. However, you can give it some things that it can't guess, and you'll get an error. So let me go back and change this semicolon back to a tilde. Oops, it's not right. So if I do this, save the file, come over here. Now, once again, I'm going to let it guess what the delimiter is, and I get an error because it can't, for some reason, it couldn't figure out that the tilde was the delimiter. So guessing is dangerous. It's better, since you have the feature, to go ahead and define what you want as your delimiter, and then things tend to work out just fine, as I did here. So same as with CSV, it will pad. So if I put the 100 there and put a 56 down here, save that file and run this, you see it padded properly with the 100 and the 56. If I have a letter other than the delimiter, so if I come in here and put an A in here, it will give me an error because of that character there. So you can't do that. And we already talked about the fact that it will guess. So that's DLM read. Now let's go on to DLM write and look at this. So let me sort of get rid of this. And then now come over here to DLM write. We're going to step through this one because there's some very interesting options with DLM write. And so we're going to step through this one and look at some files as we go. So if I begin to run this, I'm going to define A. Now, once again, we're dealing only with vectors, arrays, or matrices. We cannot write a cell array. And so as I step through here, I define A to be this. And there's a reason why I have these decimal numbers here, and I'll show you in a second. The very simple form is you get a DLM file, the file name, and then you just tell it to write the information. And what it will do is it will default to a comma as the delimiter. And so if I do this, if you notice over here in my current folder, there is no file named DLM file new. When I execute line 20, that file gets created. Let's take a look at that file. I'll double click on it, and there you go. And let's flip the screen here. So it shows me that it separated everything with a comma in this new file. Okay. All right. Back to single screen. Now, in this next one, I am defining the delimiter. Now, line 23 and 24 do exactly the same thing. And let me uncomment line 24 for a second here. Now, what happens here is in line 23, I'm explicitly saying, okay, to this file, write what's stored in variable A, and then use as a delimiter the asterisk, right? Now they do the same thing. If I execute, line 24 is the same thing, except for it did not do the parameter value pair. This one I just put the asterisk there. So you just have this one you have to sort of remember what you're doing, whereas the one on 23, I'm being very explicit about what I'm doing. So let me comment out 23 again. They will do the same thing. So I like 23 a lot better, especially in terms of teaching, because it's very clear as to what the delimiter is. And so let me run this line, and it's going to create a file new2, DLM file new2, and the delimiter is going to be an asterisk. All right, so if you look up here, it got created. I look at the file, and there are my values, and they're separated with an asterisk. Okay? So back here to our file, the next one, you can define the delimiter, and you can define the row and column offsets here with RO offset and C offset. R offset and C offset. You tell it how many rows and columns you want to offset by. This feature actually, whereas the delimiter feature is not available in CSV write, this feature is actually available in CSV write as well. However, I didn't show it there. I wanted to show it here. Okay, so now when we execute, there should be a new file, new3, which shows up here. And if you look, this one, I said 20 rows down, so it's offset by 20 rows down and 10 columns over. And what it does is put the delimiter in there to fill it. And so the delimiter, once again, is the asterisk. So that's a relatively crazy file. You can do it. I don't know what under circumstances you would, but you can do things like that as well. I think there was a question asked, can you control the precision? Yes, you can. You can do it more finely in DLM write than you can in CSV write. DLM write, you can control the precision. Over here, you put in precision and then comma, and then you put in the format just like we did in fprintf and sprintf. You put in, this one's got 0 padding, 12 total characters, and 6 past the decimal point. So 12 significant digits, and then 6 past the decimal point. And so it allows you to line up data. Also here, if you look, I changed my delimiter to a tab, which makes a little bit more sense than an asterisk in some senses. So my data comes out in nice tabular form in my file. So now I'm going to execute this one, and we'll look and see what we get in DLM file new 4. So I execute this, and then you notice what it did is there are 12 digits here, 6 to the right of the decimal point, and it's 0 padded to the left of the decimal point, and it makes very nice columns. Now, I don't have to 0 pad, and I get this data without the zeros on the front end, but I did this to show the whole formatting ability and precision ability. So that's that one. Once again, the precision feature in CSV, you default to 5 significant digits. Okay, so now here, and this is a feature of DLM write that you don't have in CSV write, is that you can actually append to a file. Recall in CSV write, you automatically overwrote a file that you had. Well, here you can actually append to a file, which is very helpful if you want to accumulate data. And as you append, you get to format what you append as well. So it doesn't have to have the default format of the data that's already in the file. You can actually make new formatting. That's what I'm going to illustrate here. So I create a new array on line 34, call it B, and then on line 35, I write to DLM file new 4.txt, which is the one we just saw here that we created on line 31. And I'm going to write the data B. I'm going to use a different delimiter. That's going to be a comma. And then I'm going to append. I have to put the append thing here, or the append parameter here, attribute here, so that it knows not to overwrite. So step through, I create B, then I do it again, and then I look at DLM file new 4, and lo and behold, there's my new data appended to the end of it. So DLM write allows you to do a lot of things. And so let me do a summary over here for DLM and do a comparison between CSV and DLM in terms of writing. With CSV, the delimiter defaults to the comma. With DLM, you have complete control and can have any delimiter. With CSV, in terms of R offset and C offset, you actually have the ability to do it with CSV, and you have the ability to do that with DLM. You have the ability to do C offset with CSV, and you have the ability to do C offset with DLM. So those are features that are similar. When it comes to precision, you have a max of 5 significant figures with CSV. You have your unlimited, have any number of significant figures and formatting with DLM. And then in terms of appending, being able to append, no with CSV and yes with DLM. So DLM is sort of an extension of CSV, or it looks like CSV is a subset of DLM. And so if you find CSV lacking, then use DLM.